Hi my dear students, welcome to my physics LCR class. Welcome to my physics LCR class. Today I am going to teach motion in one dimension. This is class 9 level actually. Okay. So in this chapter, first we are going to see the what is physical quantity. Then type of physical quantity we are going to see. First we are going to see physical quantities. What is physical quantities? The quantity which can be measured. The quantity which can be measured is known as physical quantity. Physical quantity means that quantity can be measured. That is known as physical quantity. Physical quantities, it is going to classified into two types. Physical quantities classified into two types. What are they? Scalar quantities. Scalar quantities. Scalar quantities and vector quantities. So scalar quantities are scalar we can say. Scalar we can say. So scalar quantities are scalar. Vector quantities are vector. Okay. Scalar quantities, only the magnitude, the quantity which has magnitude only, that is known as scalar quantity. The quantity which has only the magnitude, that is known as scalar quantity. What is magnitude? Magnitude means numerical value along with unit. Numerical value along with unit. Suppose distance we are measuring 30 meter, 10 meter, 1 kilometer, like this we are measuring. Then mass, what is the mass? Mass actually 1 kg, 2 kg. The material contained in the matter is known as mass. So that is a 5 kg mass. Mass and weight is different concept. Mass and weight is different concept. Already we studied. Once again I will explain afterward. But the 5 kg, 10 am. So just here you see all the things actually having number and unit. Numerical value and unit. So this is called magnitude. Magnitude means numbers or numerical value along with unit, that is called magnitude. That quantity only having the magnitude. Only having the magnitude. So this is known as scalar quantity. So example for scalar quantity: mass, area, volume, time, distance, speed. These are actually example for scalar quantity. What are they? Example: mass, area, volume, time, distance, speed. Area we can say 10 meters squared. Volume 3 centimeter cube. 7.8 centimeter cube mass per. Okay, so these are the values actually we can say actually. So these are the example for scalar quantity. Speed we can say 25 meter per second. Meter per second. Okay, so here, so these are the example for scalar quantity. So two parameters can be decided or define the scalar quantity. Two parameters defined as scalar quantity. What are the two parameters? One is numerical value of the quantity. So numerical value of the quantity. Another one unit. Another one unit. So these two things, parameter, like these two parameters determine the scalar quantity. Defined as scalar quantity. Two parameter. What are the two parameter? Numerical value of the quantity. Another one unit. What is scalar quantity? Only the magnitude. These are the example: mass, area, volume, time, distance, speed. Okay, so these are the example for here there is, we will see the vector quantity, then you can understand. Next actually, what is vector quantity? What is vector quantities? We can say vector. Vector quantities are vector. Here the quantity which has magnitude as well as the direction. magnitude as well as the direction. You know about this is magnitudes with direction. Suppose any vehicle, you are riding a bike. Your bike actually riding this speed actually 50 kilometer per hour in east, in west. So this is a scalar quantity, or this is a scalar quantity, that's a magnitude with direction. This is the magnitude. This is a magnitude with the direction. Magnitude with the direction is known as vector quantity. Have you understood? Now you can distinguish what is scalar. Scalar is only magnitude. Here I mentioned, just to see 25 meter per second, it is a speed. But here 50 kilometer per hour. Here 50 kilometer per hour in east, in west. Direction we are mentioning. Magnitude along with the direction is known as vector quantity. So these are the example I given. Vector quantity: velocity, force, acceleration, displacement. Velocity, letter capital V, F, capital F, force is F, acceleration is A, small a. Some other alphabet also used, but acceleration means A we are mentioning. Displacement D. So all the have just to see the letters, all the letters over the letter overhead we are giving a arrow mark, it is given. Why the arrow mark is given? In vector quantity, why the arrow mark is given? Arrow mark is given means it has a direction. It has a direction. This arrow mark is mentioning the direction. Arrow mark is mentioning the direction. Here velocity, force, acceleration, displacement. Okay. Weight also we can say. Weight. So suppose we are having a weight, any object having a 1 kg mass actually. Mass should be multiplied with g, it will become a weight actually. So this is a 1 kg is a mass. 1 kg mass. 1 kg mass into acceleration value is 10 meter per second square. 10 meter per second square. So it is a g value. It is a g value. Gravitational value. So this is a weight. Weight always pulling towards the center of the gravity. Our weight also, it is falling downward. It is falling downward. So that's why weight is weight. It is a vector quantity. Weight is a vector quantity. We are denoting W, but arrow mark is not given actually. It is not given a arrow mark. Weight actually, weight W we are mentioning, but arrow mark is not giving. Weight is a vector quantity. Weight is a vector quantity. Velocity I will explain. Afterward, what is velocity, what is force. Lower level you people studied actually. Velocity, force, acceleration, everything it is related. Speed, velocity, force, acceleration, everything it is interrelated. Next one, displacement. Now I will explain the displacement. What is the displacement? What is the displacement? Any problem? Have you understood? What is the scalar quantity? So this is a vector quantity, scalar quantity, magnitude, only magnitude. Vector quantity, magnitude with the direction. What is displacement? What is displacement? Displacement is a distance only. It is a distance only, but it is having a direction. Distance with the direction. One body actually, this vehicle, just to see, 50 kilometer in east. 50 kilometer in east. The body actually covering one place to another place. It is a 50 kilometer. So it is travel in a east direction. It is a travel in a east direction. One position to another position. It is one position to another position. So distance is 50 kilometer in east direction. Okay. So displacement. Displacement is a vector quantity. So it is denoted by capital D. So this is a vector quantity. This is a vector quantity. So distance means, displacement means distance with the direction. Displacement means distance with, here it is given, see distance. Distance is a scalar quantity. This displacement is a vector quantity. So next class actually we are going to study the distance and displacement. That's why I am explaining here. Distance, displacement. Distance is a scalar quantity. This is a vector quantity. Okay. So here also vector quantity going to determine by three parameters. Three parameters can be defined as the vector quantity. Three parameter. What are the three parameter? Here it is written three parameter. Already you know it, you are familiar with these two things. Numerical value of the quantity. Numerical value of the quantity. Second one is unit. Next one is direction. That is I told 50 kilometer per hour. This is numerical value along with this unit. So this is a magnitude. Magnitude along with direction. So this is, we can say this is speed even though. This is a speed. 50 kilometer per hour, 100 kilometer per hour, 200 kilometer per hour, 600 flights, no, they are having a speed is very more actually. Per hour 400 kilometer, 500 kilometer. It is travel with the speed. Aircraft travels with the speed 500, 600 kilometer per hour actually. So I will explain what is this next class only. But this is about the speed. Speed is a scalar quantity. With the direction, it will become a vector quantity. So this is, we can say, 50 kilometer per hour in south. This whole thing we can say it is a velocity. Understood? My dear student, understood? So this only the speed. When direction is mentioning, it will become a velocity. Next class I will explain properly all the things. Okay. So speed is a scalar quantity. Velocity is a vector quantity. Any problem? 50 kilometer, 25 kilometer per hour. It is a speed. With direction, in east direction, in west direction, in north direction, any direction, it will become a velocity. Any problem? Just to go through it properly, you can understand. So vector quantity. So this is having a three parameter determining the vector quantity, numerical value, unit, direction. So for scalar quantity, just to see 30 meter. Here 20 meter in east. It is a distance, it is a displacement. This is a displacement. 25 kilometer per hour. This is what? This is a speed. 25 kilometer per hour is a speed. Same thing here, just to see 25 or 250 kilometer per hour in south. How you are going to give a direction in geography? You people study this type of thing actually. Just you see, it is a center point. This is north. This is south. This is east. This is west. Map, you people don't know. All the maps know this type of diagram is given. So that is the direction we can understand. So 250 kilometer per hour in south. So I am starting from here. So south direction I am going to travel. So 20 meter in east I told actually. So here I am going to start. And that's the origin or center point we can say. So east direction I am going to travel. East direction. Have you understood? Any problem? This is scalar quantity. This is vector quantity. Magnitude only. Magnitude as well as the direction. This is numerical value of the quantity and the unit. Here just to see numerical value of the quantity, unit, direction. Three things are there. So these are it is having a 2 parameter scalar quantity. 3 parameters are there. Quantity of, numerical value of the quantity, unit, the direction. So it is a vector quantity. Next actually we are going to study about the 3-dimensional motion. 1-dimensional motion, 2-dimensional motion, 3-dimensional motion. What is 1-dimensional motion? What is 1-dimensional motion? Body actually moving in a straight line path. Body moves in a straight line path. That is known as 1-dimensional motion. When body moves in a straight line path, it is known as 1-dimensional motion. Body move in a curved path. When body moves in a curved path, we can say like this, any curved path. So it is a 2-dimensional. This is 1 dimension, this is 2 dimension. This is 2 dimension. Third one, in space. Body actually flying in space actually, in space. Aircraft, no, aeroplane, these are the things flying in a sky. It is flying in a sky. It is a called 3-dimensional motion. 3-dimensional motion. 1-dimensional motion also known as linear motion. 1-dimensional motion is known as linear motion. Another name of 1-dimensional motion is linear motion. Body moves in a straight line path. Okay, it is a 1-dimension curved path. It is a 2-dimension. In space, the kite we are giving, it is flying in a sky. It is a space we can say. So it is a 3-dimensional motion. Okay, so 1-dimensional motion, 2-dimensional motion, 3-dimensional motion. 1-dimensional motion, how we can plot in the graph. You people have seen graph paper, no? That is a checked paper. So graph paper, 1-dimensional motion, how we are mentioning, it is a horizontal line. It is a x-axis only we are mentioning. Distance and time. Suppose 1 meter, 2 meter. So time is 0 second, first second, second. So it is a 1-dimensional motion we can draw in a graph paper. Plotted in a graph, we can plot in a graph paper. So it is a straight line we can do. It is a 1-dimensional motion. 2-dimensional motion like this, y-axis, x-axis. This is a y-axis, this is a x-axis. 2-dimensional motion we can plot in a graph. 3-dimensional motion, this is a 1-dimensional motion, this is a 2-dimensional motion. 3-dimensional motion, how we are going to plot, just to see. This is like this. This is y-axis, this is x-axis, this is z-axis, space. 3-dimension we can plot in a graph paper. 1-dimension graph, 2-dimension graph, 3-dimension graph. So 1-dimension motion, 2-dimension motion, 3-dimension motion. What is 1-dimension motion? Body move in a straight line path. Body move in a straight line path. Straight line path. This is called 1-dimension motion. Another name is linear motion. 1-dimension motion is known as linear motion. Linear motion also, when body moves in a straight line path, you are throwing a stone upward direction. You are going to throw any object upward. Straightly it will go. So body you are going to drop. This is also 1-dimension motion. You throw the object, it is going upward. It is a 1-dimension. Just you drop any object, it is also 1-dimension. when you are riding any vehicle in a crowded place, not like this zigzag type we are going, it is a two-dimension motion. In sky, any object it is flying in space, so that is called three-dimensional motion. One-dimension motion, three-dimension motion. These are the graph we are going to plot. This is a one-dimension motion graph. This is a two-dimension motion graph. This is a three-dimension motion graph. Clear, all of you? So in this portion we studied physical quantity, scalar quantity, vector quantity, definition and the examples. Okay. Next actually different type of motions, dimension of motion, one dimensional motion, two dimensional motion, and a little graph also I explained. Okay. I am going to stop this class now. Study well, go through it properly. Okay. Daily you have to study. You have to apply the effort. Higher classes, junior class also you study, but when you are going to upper classes, no, little more effort you have to apply. Little more effort you have to apply. You can get a good marks. This is finally what is we have to achieve the marks. Okay. Thank you. Thank you.